Hi guys. Okay, so we are looking at chapter 9, solutions, and we are continuing with, in this brief lecture, the concepts on equivalence and then the solution concentrations, which is mass by mass percent, volume by volume percent, mass by volume percent, molarity, and the conversion factors. So first of all, what are equivalents? Equivalence is the amount of ions, okay, which are equal to 1 mole of positive or a negative charge. So that is a very basic definition of this concept. So now let's look at it. Number of ions, so or the ions or the types of ions. So for example, if you have like sodium ion, lithium ion, potassium ion, or even ammonium ion, okay, ammonium ion. So these guys will have +1 charge. So what is the equivalent? Equivalent is 1 equivalent. Okay, if you have 2 charges, such as in calcium ions, +2 charge, let me put this as 1, 1, 1, 1, +2 charge, magnesium has +2 charge, then the charge is +2 and the equivalent is 2 equivalents. If you have like iron with +3 charge, like aluminum with +3 charge, right? Like, so in that case, you will have the charge is +3 and the equivalents are number of equivalents. 3 equivalents are in 1 mole. On the other hand, if you have the negative charges, such as chloride, such as bromide, such as iodide, all -1 charges, other ones are like, for example, acetate, CH3, COO, -1 charge, right? Or if you have like other ones are like ClO4, -1 charge, right? Or if you have like H2PO4, -1 charge, all of them will have -1 charge, and the milliequivalents, the equivalents, sorry, in 1 mole is still it's 1 equivalent. Okay, next is if you have, for example, carbonates, right, -2 charge. Let's say you have sulfates with -2 charge, then the charge is -2 and the equivalence is 2 equivalents, right? If you have phosphate, PO4, with -3 charge, then it will have a -3 charge. The equivalents are 3 equivalents. So you see, it's just the number of charges, okay? Now, let's look at this problem here. Study check 9.2. Study check, and how do you use this information? So study check 9.2, okay? A lactated Ringer solution of intravenous fluid replacement contains 109 milliequivalents of chloride ions, okay, per liter of solution in 1 liter. So per liter solution. Okay, so that means 109 milliequivalent of chloride ions is equal to 1 liter solution. So this is another way of saying this, okay? If a patient received 1,250 milliliters of Ringer solution, how many moles of chloride ions were given? Chloride ions, how many moles? Okay, so how do you do this? So first thing you should know is a very simple thing, that 1 equivalent of anything is equal to 1,000 milliequivalent. So it's basically, you know, 1 equivalent is equal to 1,000 milliequivalent. So the conversion factors would be 1 equivalent over 1,000 milliequivalent, or 1,000 milliequivalent over 1 equivalent. Okay, then what is given to us? You are given this thing. This is in a way known, you know, this is known, and you are given 1. So let's write this down also the same way, that you are given 109 milliequivalent of chloride ions over 1 liter of this solution. Okay, another conversion factor is 1 liter of solution over 109 milliequivalents of chloride ions. Okay, so we this is now for a chloride ion. How do you write this? For a chloride ion, it is, when we say chloride ion, 1 equivalent of chloride ion. What does that mean? 1 equivalent means number of equivalents in 1 equivalent of chloride ions in 1 mole. In 1 mole based on the charge. Okay, so in other words, 1 equivalent chloride ion over 1 mole. Okay, 1 mole of chloride ion. So 1 equivalent of chloride ion is equal to, based on the ionic charge. So this is based on the charge. That is a relationship between the charge and the equivalent. So 1 equivalent is in 1 mole based on the charge, because the charge is based on the charge of -1 charge. So this is the conversion factor, or 1 mole of chloride ion over 1 equivalent chloride ions. Okay, so you have now seen that you need to find the chloride ions. So you are going to, sorry, let's just do this. Okay, so 1 mole of chloride ion. So you need to find the moles of chloride ions. That's one thing, moles of chloride ions. So definitely this is what you will use. You need to get rid of the equivalent of the chloride ions. And the equivalent of the chloride ions are, this is the equivalent, 1 over. So this one is the one you will, these are the 2. So one of them you will use, which gets rid of the equivalent of the chloride ions. But this equivalent needs to be converted to milliequivalents, because that's what is given to you. You are given 109 milliequivalent present in 1 liter of solution. Okay, so you need to remove the milliequivalent to equivalent. So you will use one of these conversion factors. Okay, and then this is the one that you need to find for in 1250 milliliters of the solution. Okay, so let's do this. 1250 milliliters of the solution. Okay, solution times okay, so I've done this for you. So let's do this, the first step. So we will first find the equivalence of chloride ions in 1250 milliliters of the solution. Okay, and then we are going to convert those equivalents to moles. So we are given, first of all, a milliliters. We are given 1250 milliliters of the solution. Convert that milliliters of the solutions to liters of the solution. Okay, next is what is given to us is this 105 milliequivalents of chloride ions are present in 1 liter of the solution. So this was the reason why we needed to convert the milliliters to liters of the solution. Okay, next is, this is the solution. And in this solution, there are 109 milliequivalents of chloride ions present. So here, when you cancel out the liters, we are just left with the milliliters of chloride, milliequivalents of chloride ions that are present in 1250 milliliters of the solution. So we get 136.25 milliequivalents of chloride ions. Now, remember that here we talked about that this is the equivalence of the chloride, equivalence of the ions in 1 mole. So here we have the answer in milliequivalents. So now you are going to do the conversion from milliequivalent to equivalent. So that is you are going to times 1 equivalent over 1000 milli equivalent. Okay, so that cancels out the milli and you get it 0.136 equivalent of chloride ions. Next is you're going to use this, we know that the equivalent of the number of equivalents of the ions in 1 mole is, we need to find the moles of the chloride ions, and so we have the charge -1, so therefore the equivalent is also 1. If the charge was 2, the equivalence would be 2. So this is the charge related. Okay, this is the charge related. So you take whatever the equivalent of chloride ions you have times. So this is converting the equivalents to moles using this as a conversion factor. That is 1 equivalent of the ion over 1 mole of that ion. And it depends on the charge on the ion. So if it was not chloride, it was sulfide, it would be 2. If it was 1 mole over 2 equivalents. Okay, so keep this in mind that, let me write this down, that if it is sulfide, then it would become -2. It's sorry, the number of equivalents is 2. The charge is 2 -2. So it would be 2 equivalents of sulfide ions, let's just write this here, sulfide ions are present in 1 mole. 1 mole of sulfide ions. 1 mole, okay, and then 2 equivalents of sulfide ions in 1 mole. Similarly, if you have phosphorus with 3 charges, this would become 3 equivalents of phosphide ions, phosphide ions in 1 mole. 1 mole. And if you have, like, for example, if you have like lead with +4 charges, then it becomes 4 equivalents of lead ions in +4 state present in 1 mole. Okay, so here is this 1 mole of basically sulfide ions, 1 mole of phosphide ions, and 1 mole of lead ions +4. Okay, so this is the way you do this part. Now let's look at the next part, which is the concentrations. Okay, the solution concentration, and that is the 9.4. 9.4 concentration. Now, when we talk about concentration, concentration means the amount of solute present in, amount of solute present in, amount of solute present in the total solution. Okay. Now, there are different types. One is mass by mass concentration, mass by mass percent. So this is mass, means the weight of the solute in grams, okay, in grams over the weight of the, or the mass of the solution in grams, okay, times 100, times 100%. And that is going to give you the mass by mass. Okay, so let's look at the one example here. When we talk about the solution, just remember that solution is what? Solution, whatever it is, whether it is the mass or whether it's volume, is basically made up of solute, the amount of solute plus the amount of solvent. So solute plus solvent is the solution. Okay, so just make sure that the units are the same for both. Okay, so for example, let us say you have an example here is 10 grams of sugar present in 50 grams of water. So it's very important you recognize that grams of sugar, low amount, is acting as a solute, and 50 grams of water is acting as a solvent. So the total weight of the solution is going to be, total weight of the solution is, total weight of the solution is equal to 50 plus 10. So the total weight is 60 grams, and that is what you will use. So the next is the mass by mass percent is equal to 10 grams sugar over 60 grams of solution. 60 grams of solution times 100%. And what are you going to get? So it is 16.66%, and you can say it as 16.67 or 16.7%, and it can also be 17%. So it doesn't matter, it could be one of the choices, but it is going to be mass by mass percent. That's the unit. So the unit of this answer is 16.66. I'm going to just keep it like that, 16.66 mass by mass percent. That is what you will write. Okay, now let's look at this study check problem here. Study check 9.6, study check 9.6, and this is page 340, page 340, and you are going to put here, what is the mass by mass percent of sodium chloride in a solution made by dissolving? So you are given 2.0 grams of NaCl in 56.0 grams of water and 56.0 grams of water. So it's very important you recognize that this is the solute and this is the solvent. Water is the solvent. So the total weight of the solution is, so total mass of the solution is equal to 56.0 plus 2.0 grams, and that is 58.0 grams. So the mass by mass percent is equal to 2.0 grams NaCl divided by 58.0 grams of solution times 100%. Okay, so let's see what you get here. So the answer is 3.44% mass by mass percent, and you can also write it as 3.44 or 3.4 mass by mass percent. Okay. All right. So that is generally you need to write down what is the solute. What are we talking about? NaCl solution. Okay. So in what context? Next is the volume by volume. So volume by volume percent means that volume in milliliters, volume in milliliters of the solute over the volume in milliliters, volume in milliliters of the solution times 100%. Okay, so just like this one. So same thing, solute in solute. Now this volume in milliliters of the solute, it could also be in liters also. Okay, but generally in the labs, we take it in the milliliters. So for example, let's look at this. What is the volume by volume percent of bromine in a solution? So we'll just straight away do the study check problems because it is self-explanatory in the study check problems. So here is a study check problem 9.7, and that is page 341. Page 341. So what do you have here? You have here, what is the volume? What is the volume? What is the volume? Volume by volume percent of bromine, Br2. Now, bromine is a liquid. Okay, so that is why. Of bromine in a solution prepared by dissolving 12 milliliters of liquid bromine in liquid, okay, in the solvent of carbon tetrachloride. Bromine is dissolved in carbon tetrachloride, which is a solvent. Okay, so they are saying that this is a solvent and this is a solute. And when these two are added together, 250 milliliters of solution is produced. So 250 milliliters of solution. So the question is already telling you that the solution is, the volume of the solution is given. Okay, so you will have 250 milliliters of bromine, Br2, over 250 milliliters of the solution. Okay, times 100%. And here you get 12 over 250 times 100%. So let's do the math. So the answer is 4.8 percent volume by volume percent of what? Bromine dissolved in carbon tetrachloride solution. So it's very important you write down in what context it is. Okay. Next is the mass by volume percent. Mass by volume percent is M over V percent, which means mass of the solute. So all the time solutes are going to be on the top, and the volume of the solution, always solution at the bottom, solution. So mass is in grams and the solution is in milliliters, and sometimes it's in liters, it doesn't matter. Okay, so this is n times 100%. Okay, so what do you get here? You have all right, so 9.8. So let's do this problem. 9.8 study check. 9.8, and this is page 342. Page 342. So how do you do this? So you're going to take, in this case, what is the mass by volume percent? M by V percent of sodium hydroxide, of sodium, NaOH, sodium hydroxide. Now, sodium hydroxide is a solid, okay, prepared by dissolving 12 grams of NaOH. So this is given is 12 grams of NaOH, okay, in water to make 220 milliliters of solution. So you are given the mass of the solute and you are given the volume of the solution, mass of the solute over the volume of the solution. So all you need to do is you're going to put 12 grams divided by 220 milliliters of solution. So this is, always write down solution here, and this is 12 grams of NaOH. Always write down what is in what context, times 100%. And you are going to get, let's do the math. Okay, so it is 5.45% mass by volume percent, right? And that is NaOH in solution, or NaOH solution, basically NaOH in water. And so so it's a solution when generally, you know, ionic compounds, NaOH solution. So ionic compounds are always in water. Okay, so now this thing can also be written as 5.45 becomes 5.5% mass by volume percent, NaOH. So either way you can, you could, have 5.45 or 5.5, okay? Next is molarity. Next is the concentration, is the molarity. Now, molarity is number of moles per liter. Molarity is equal to number of moles of what? Of solute. Moles of solute over 1 liter of the solution. 1 liter of the solution, okay? Now, moles of the solute. Now, sometimes if you're given the grams of the solute, you are going to convert that to moles of the solute, moles of the solute. And this moles of the solute are you're going to get through the molar mass. So take the molar mass and do that conversion. So this is one piece, very important. The second piece is important is generally we conduct our our measurements in the labs using the these equipments or these what are these called? These apparatuses, which are, the measurements are in milliliters. And so convert the milliliters to liters using the conversion factor 1 liter over 1000 milliliters. So basically that is the like a conversion factor you have to multiply. Okay, so here let's do the study check problem. Study check. Study check is 9.9. Okay, and this is on page 343. Okay, so here, what is the molarity of a solution? So find the molarity of a solution that contains 75.0 grams of KNO3, okay, dissolved in 0.350 liters of solution. So here we will have to, liters is good. So this is good for us. So we don't need to convert, but this one we need to convert to moles. So here convert to moles of KNO3. And here we are going to find the molar mass of KNO3. So we have 1 potassium, we have 1 nitrogen, and we have 3 oxygens. And the mass of potassium is 39, nitrogen is 14, and oxygen is 16. So 39, 14, and 16. So here you have 39, here you have 14, and here you have 16. 3s are 48. So you add these, and what do you get? Okay, so you have 101 grams per mole of KNO3. Okay, so 101 grams of KNO3, convert that to moles. Okay, sorry, it's not 101, it is 75 grams. So 75.0 grams of KNO3 times 1 mole of KNO3. So this thing you learned earlier, 1 mole KNO by 101 grams of KNO3. So this is 0.742 moles of KNO3. Okay, so why did I use 0.742? Because 3 significant figures. So these are 3 significant figures, 3 significant figures. So we need to put 3 significant figures. Okay, anyways, so let's just put it here. 3 significant figures. So the answer should also be in 3 significant figures. All right, next is you take these moles, we have 0.350 2.742 moles of KNO3, and you divide that by the volume that is given, 0.350, 0.350 liters of solution. And what do you get here? Okay, so this comes out to be 2.12 molar KNO3 solution. Okay, so always write down the name of the chemical that is associated with those numbers. Okay, now let's look at the conversion factors. Conversion factors. Now, in these conversion factors, we're going to see how do these look like. Okay, so if you have 10% or let's say 15% mass by mass sodium chloride solution, what does this mean? Sodium chloride solution, what is the meaning of this? This means that 15 grams of NaCl, okay, 15 grams of NaCl is dissolved in 100 grams of solution. Okay, and the conversion factors are 15 grams NaCl over 100 grams total solution, 100 grams of solution. Or, 100 grams of solution over 15 grams of NaCl. Okay, now let's look at if you have 10% volume by volume, okay, alcohol solution. Okay, so this means 10 ml of alcohol is present in 100 ml of solution. Okay, this also means that 10 ml of alcohol over 100 ml of that alcoholic solution, basically, or 100 ml of alcoholic solution over 10 ml, 10 ml of alcohol. Okay, next is if you have, let us say 2% mass by volume sugar solution. So what does this mean? This means that 2 grams of sugar is present in 100 milliliters of solution. This means 100 milliliters of solution over 2 grams of sugar. These are the conversion factors, or 2 grams of sugar over 100 milliliters of solution. Okay, and last but not the least is the molarity. So if you have 2.0 molar HNO3 acid, so this is the nitric acid. Okay, so what is the meaning of this? This means 2.0 moles of HNO3 are present in 1 liter, of the solution, and at the acidic solution. Okay, in 1 liter of solution. So what are the conversion factors? 2.0 moles HNO3 over 1 liter of solution, or 1 liter of solution over 2.0 moles. All right. So for now, we are going to stop here. Then we are going to look at a little bit more complex problems, which is 9.10. Then I'm going to look at these solutions, the end and the dilution of the solution, and then the properties. So I'm going to stop here and we'll carry on in the next video. All right. Thank you for watching.